Hi everyone, this is Mrs. GA, and today we're going to talk about how to describe where a function is increasing or decreasing and average rate of change of a function. Okay, so to determine whether a graph is increasing or decreasing on a given interval, we're essentially going to be comparing the y values between two different x values. So for the first one, it says if f of x is increasing on an interval, if f of x sub 1 is less than f of x sub 2 when x sub 1 is less than x sub 2. So let's see if we can interpret what this means. So let's say I have a graph that looks like this. And let's call this point x sub 1, and let's call this point x sub 2. So all we have to know is that x sub 1 is a smaller x value than x sub 2. So if I compare their y values, I can see this would be f of x sub 1, and this is f of x sub 2. So I can see that f of x sub 1 is less than f of x sub 2. So this graph is increasing. Of course, another way of looking at this is if you read the graph from left to right, our graph would be going up. Let's look at the next one. It says f of x is decreasing on a given interval if f of x sub 1 is greater than f of x sub 2. So again, let's look at a case like this. Maybe we'll call this value now x sub 1, and we'll call this one x sub 2. So again, x sub 1 is still smaller. So if I find their corresponding y values, this would be f of x sub 1, and this would be f of x sub 2. I can see that f of x sub 1 is greater than f of x sub 2, which means that my graph is decreasing. And of course, again, if you read your graph from left to right, I can see that our graph is going down. So that's how we can tell just by looking at the graph. And last, when is a graph constant? So it's just like a constant function, essentially a horizontal line. So a graph is constant when f of x sub 1 equals f of x sub 2. So again, here's what it looks like. Let's call this x sub 1. Let's call this x sub 2. Well, I can see that f of x sub 1 is equal to f of x sub 2 because our graph is constant. So that's how you can tell by looking at the equations, but of course you can also tell by looking at whether your graph is essentially going up, going down, or is horizontal. Okay, so let's see if we can describe when this function is increasing and decreasing. So we are going to be using interval notation for this. So let's start about when our graph is increasing. I like to actually highlight or color my graph. So I see that my graph is going up all the way until I reach my maximum point right here. And again, we always read our graph from left to right. I understand that this arrow kind of makes it seem like we should be going down, going in this direction, but we always read our graph from left to right. So this is the area where our graph is increasing. The way we describe that is from negative infinity, because I see the arrow going to the left, and all the way up until this x value. We're always working with x values, which is negative 3. And we will include that in our interval. Now let's talk about where our graph is decreasing. So again, I'm going to highlight. It's from our maximum, and then it's going to go down infinitely to the right. So that would be from negative 3 to positive infinity. And again, notice that I am including my turning point in both intervals. Okay, let's try this next one together. So here I can see that I have 3 different intervals to describe. Let's start with increasing again. So I can see that my graph is increasing from negative infinity all the way up until this point. And then it's going to decrease a little bit, but then it turns around and it increases again in this interval. So let's start by naming this interval. So this interval would be negative infinity until 0. Remember, we're naming the x values where it's increasing. Negative infinity to 0. Or I need to name this interval now. So this is when x is 2, and then it continues through infinity. So 2 to infinity. And of course, infinity is never included. Now let's describe where our graph is decreasing. That would be in this zone right here. So it starts decreasing when x is 0. And it keeps decreasing until x is 2. And there you have it. Okay, go ahead and pause the video and see if you can determine where this function is increasing and decreasing. Okay, let's check our answer here. So again, for increasing, if it helps to highlight, you should definitely do that. I can see that's increasing from -1 to 0, and then from +1 to positive infinity. And my graph is decreasing from negative infinity to -1 and 0 to 1. Okay, so now we're going to talk about how to find the average rate of change of a function between two given x values. So the average rate of change between x equals a and x equals b is essentially just the change in y over a change in x, which can be found with f of b minus f of a over b minus a, which you might recognize is essentially just the slope formula. So again, you can find the average rate of change between any two x values on a function by essentially doing the slope formula. Here's a quick reminder that linear functions have a constant rate of change, which is their slope. So if you're ever asked to find the rate of change between any points on a linear function, you can save yourself a little bit of time. It's always going to be the slope of that function. Okay, so let's try this last example together. We'll do part A together. So here we have f of x equals x minus 3 squared. So we have a quadratic function, and we'd like to calculate the average rate of change first between x equals 1 and x equals 3. So to do this, we're just going to essentially do f of 3 minus f of 1 all over 3 minus 1. So this is like y2 minus y1 over x2 minus x1. It's essentially just the slope formula. So if I substitute 3 into my original function, f of 3 would be 0 minus f of 1 would be positive 4 over 3 minus 1. So our average rate of change is -4 over 2, which is -2. All right, why don't you go ahead and pause the video and see if you can give part B a try. Okay, go ahead and check your work here. So you can see here's essentially our average rate of change formula, which is the slope formula. And if you simplify, you should get an average rate of change of 5. All right, that is all for today's video. Thank you so much for watching.